Welcome back to the deep dive. You hand us the essential reading, the research papers, the critical articles.
And we hand you back the distilled knowledge, basically the fastest way for you to get up to speed and, well, sound like the smartest person in the room.
Today, we're diving into something really fundamental, power independence. And, it feels like power used to be maybe a convenience.
Right.
But now, with smart homes, remote work, digital health devices, reliable power is just absolutely non-negotiable. It's a necessity.
Oh, completely. Losing power today isn't just, fumbling for candles. It's serious. Your communication lines could go down, security systems fail.
Yeah, and think about medications in the fridge.
Yeah.
Or if you work from home, your whole livelihood just stops.
Exactly. Food spoilage, lost work hours. The stakes are just, incredibly high now compared to even 10 years ago.
So the sources we're looking at today really set up a head-to-head comparison, right, between the two main players in the generator world.
That's it. We've got the traditional generator, the kind you've probably seen or definitely heard, and then the newer, more techie inverter generator.
Okay.
And our mission here really is to go beyond just the spec sheets. We want to equip you, the listener, with the kind of deep understanding you need to pick the right tech for your situation. We're talking wattage, sure, but also noise, fuel use, and maybe most importantly, power quality.
Okay, let's unpack this. Let's start with the classic, the undisputed heavy lifter.
Right.
The traditional workhorse generator.
Right. The workhorse. That's a good way to put it. I mean, these are the machines that basically built America's backup power grid, right? For decades.
It feels substantial.
They are robust, built to last. And the process is pretty straightforward. Burn fuel, spin an engine at a constant speed, usually 3,600 RPM, flat out to make AC power. It's all about raw, brute force electricity.
And the big advantage reading through this seems to be just pure scale. If you need serious juice, whole house, pump, furnace, maybe big tools on a job site.
That's where they shine, that high wattage output. Often for that kind of load, the traditional generator is really the only option that fits a reasonable budget.
Yeah, the price point is definitely a major factor mentioned in the sources.
Yeah.
You can get started for, around $300?
Yeah, roughly. Starts around there. So you get a lot of potential power for your initial investment. If upfront cost is your absolute main driver, traditional units, they often win.
And they seem pretty flexible fuel-wise, too. Gasoline, propane, diesel, natural gas, depending on the model, of course.
Right. That fuel flexibility is a big plus. You can often choose what's easiest for you to get, or maybe what's best to store long-term if you're prepping for extended outages.
Okay, and durability, they look tough.
They generally are. Built with pretty heavy-duty components, designed for rough use, maybe sitting out in the weather. And because the mechanics are, let's say, less complex than an inverter's electronics. Simpler, exactly. Maintenance and repairs tend to be more straightforward, less specialized maybe, and potentially cheaper over the life of the machine. You're buying tech that's been around, refined for ages.
Okay, so powerful, relatively affordable, durable, flexible fuel. Sounds pretty good. So why the need for an alternative? There have to be downsides.
Oh, there are. Big ones. And the first one usually hits you right in the ears. The noise.
Yes, the noise.
If you've ever been near one running, it's loud. Seriously loud. The sources put it at 70 to 90 decibels.
Which is what does that compare to?
Think of a gas-powered lawnmower running right next to you. Or maybe heavy traffic. It's not background hum, it's intrusive. Forget having a conversation nearby. And your neighbors, they won't be thrilled.
Yeah, okay. Big drawback, especially for residential or camping. What's the other main issue?
The other major trade-off, and this is crucial today, is power quality. Because that engine is just hammering away at a fixed speed.
3,600 RPM, you said.
Right, constantly. The electricity it puts out isn't smooth, it's variable. The term often used is dirty power.
Dirty power. Okay, what does that mean practically?
Practically, it means the voltage isn't stable. Imagine electricity as a smooth wave, a sine wave. The power from a traditional generator. That wave looks choppy, erratic, spikes, dips, especially when a large appliance cycles on or off.
Like a fridge compressor kicking in.
Yeah.
Or an air conditioner.
Exactly. That creates a sudden demand, causing a dip or maybe a surge in the voltage.
And that brief instability, even for a split second.
Yeah.
That's the danger to modern electronics.
That's the killer. Laptops, smartphones, smart TVs, gaming consoles, even things like CPAP machines or sensitive network gear like Starlink, they rely on clean, stable power.
So that duty power could actually damage them. fry a motherboard or something.
It absolutely can. Or cause constant reboots, malfunctions. The cost of replacing your high-end electronics could easily wipe out any savings you got on the generator itself. That's a real risk you take with dirty power.
Okay, so the trade-off for that raw power and lower price is significant noise and potentially risky power for anything sensitive.
Pretty much sums it up.
So if that's the situation, there must be a better way, especially for homeowners or people on the move. Here's where it gets really interesting, how the cutting-edge technology directly handles these drawbacks.
Yeah.
Let's dive into the inverter generator.
Right, the inverter. This is really the evolution, designed specifically for our modern electronic-heavy lives. If the traditional unit is about brute force wattage,
The inverter is about finesse.
finesse, exactly. Stability and silence are the priorities here.
So how does it achieve that? What's the tech difference?
It's a multi-stage process, actually quite clever. First, the engine generates AC power, like the traditional one, but it's often high-frequency AC. Then, crucially, an electronic rectifier converts that AC into DC power.
So you're like battery power.
Sort of, yeah. Stable DC. Then, a sophisticated inverter circuit takes that smooth DC power and converts it back into perfectly clean, stable 120-volt AC power, like the power you get from your wall outlet.
So that conversion process is the magic step. It cleans it up.
That's the key. It completely isolates the final power output from the engine's raw output or speed fluctuations. The result is that smooth sine wave we talked about, very low harmonic distortion.
Meaning it's safe for electronics.
Totally safe. Laptops, tablets, medical equipment, smart home hubs, game consoles, anything sensitive is protected. That's probably the single biggest selling point for many people.
And the noise, you mentioned silence.
Well, maybe not complete silence, but the difference is night and day. Remember the 70, 90 decibels for the traditional?
Lawnmower's loud, yeah.
Inverters typically run between 50 and 60 decibels.
Which is more like?
Normal conversation level. Or maybe the hum of your fridge or a window air conditioner. You can actually stand next to it and talk without shouting. It makes a huge difference in a campsite. Or, if your house is close to your neighbors.
That quieter operation must tie into efficiency too, right? If it's not always running full blast.
Exactly. That's the other massive advantage. Since the inverter handles the power cleaning, the engine doesn't need to run at a constant 3,600 RPM. It has smart throttle control.
Meaning it adjusts its speed?
Precisely. Based on the actual power load you're drawing. If you're just charging a phone and running an LED light, the engine idles way down, sipping fuel.
Okay.
Then, if you turn on, say, a coffee maker or a microwave, it instantly revs up to meet the demand and then throttles back down again as soon as the load drops.
That sounds much smarter. And the fuel savings must be significant.
Huge. The sources indicate inverters can be up to 40% more fuel efficient than traditional generators.
Wow, 40%.
Yeah, because that traditional unit is just guzzling fuel at full speed all the time, whether it needs to or not. So with an inverter, you get much longer run times on a single tank of gas. Less refueling hassle, less fuel storage needed.
And they seem geared towards mobility, too. The designs look more compact.
Definitely. They're typically built with lighter materials, more compact casings, often with handles designed for carrying. Think RVing, camping, tailgating. You can often lift a decent-sized inverter with one hand.
Which you absolutely cannot do with the big traditional unit.
No way. Those often need wheels, maybe two people to move. Inverters are designed for portability.
Okay, so cleaner power, much quieter, way more fuel efficient, and portable. Sounds like the clear winner. So why doesn't everyone just buy an inverter? What's the catch?
Well, there are a couple of key trade-offs. First, generally, they don't reach the same massive peak wattage outputs as the biggest traditional generators. There's a limit to how much power you can squeeze through that complex inverter circuitry efficiently.
So maybe not enough for a whole house with central air and everything running?
For the very largest loads, a big traditional unit might still be the only option, or you'd need multiple inverters. And that leads to the second trade-off, cost.
Right. All that advanced tech isn't cheap.
Exactly. The starting price point for an inverter is noticeably higher than for a basic traditional generator. You're paying a premium for the clean power, the quietness, the efficiency, and the portability.
But I saw something about linking them together. Parallel capability.
Yes. That's a really neat feature on many inverters. You can buy a special cable and connect two identical or sometimes compatible inverter units together.
And that doubles the power?
Effectively, yes. It doubles your available wattage. So you could have two smaller, easier to handle units that you can use individually for small tasks, but link them up when you need more power, like for running an RV air conditioner. It adds flexibility.
Okay, interesting. So it sounds like the ideal user for an inverter is someone who really values quiet, needs portability, and absolutely must protect sensitive electronics. Campers, RVers, maybe homeowners who primarily want to keep lights, fridge, and like their home office running safely.
That's a perfect summary. It's about matching the generator's strengths to those specific priorities.
All right, now that we've kind of defined both camps, let's put them side by side directly. The ultimate comparison. Because making this choice means accepting the limitations of whichever one you don't choose.
Good idea. Let's tick through the key comparison points from the sources. Noise level. We've got 70-90 decibels lawnmower loud for traditional.
Versus 50-60 decibels conversation quiet for the inverter. Huge difference there.
Massive. Next, fuel efficiency. Traditional. Constant high consumption because it's always running full throttle.
Versus the inverter. Adjust to the load, potentially using up to 40% less fuel. That adds up, especially in a long outage.
Definitely long-term cost factor. Then portability. Traditional. Heavy, bulky, often needs wheels, more of a fixed asset.
Inverter, lightweight, compact, designed to be carried easily, ideal for mobile uses.
Right. And the big one, price range. Traditional starts lower, maybe $300 up to $3,000 or more for really big units.
Inverter starts higher, say $500, and can go up to $4,000 or even more for the higher wattage or premium models. You're paying for the tech.
You are. Although there's a subtle point about lifetime cost in there too. Something about maintenance.
Oh, yeah?
Well, think about it. That traditional engine running constantly at 3,600 RPM, that's a lot of wear and tear. More frequent oil changes, potentially spark plugs, general servicing.
Whereas the inverter, because it throttles down when the load is light.
Exactly. The engine runs less hard overall, so potentially longer engine life, maybe slightly less frequent maintenance intervals. It's not a huge factor maybe, but it could subtly close that cost gap over many years of ownership.
That's a really good point. The initial price isn't the whole story. Okay, so this brings us to the crunch time, the decision guide. Based on everything, when should someone definitively choose one over the other?
All right, let's break it down. You should probably choose a traditional generator if. First, your absolute priority is maximum raw power output for things that aren't sensitive to dirty power.
Like running a construction site, big power tools, a well pump, maybe just basic large appliances in an emergency, stuff that doesn't have delicate microchips.
Precisely. Second, if budget is the number one overriding concern, the lower upfront cost is undeniable.
And
third, maybe if the generator is going to live in a fixed spot, far from neighbors or living areas where the noise just isn't a major factor, like a shed backing onto woods, or for purely emergency use where comfort is secondary to just having power. Raw wattage and low initial cost are your goals.
Okay, makes sense. Now the other side.
Okay, conversely, you should probably choose an inverter generator if. Number one, quiet operation is really important for camping, RVing, tailgating, or just keeping the peace in your neighborhood during a blackout.
Number two, if portability is key. You need to move it around easily, store it compactly.
Yep. And number three, and this is often the deciding factor, if you absolutely must power sensitive electronics safely. Laptops, TVs, medical devices, modern appliances with control boards, that clean power is non-negotiable.
And maybe a fourth point, if fuel efficiency and longer runtimes are critical, maybe you anticipate very long outages or want to minimize how much fuel you need to store and handle.
That's a great addition. Yes, efficiency and runtime are major inverter strengths.
So if we boil it all down,
if we connect this to the bigger picture, the generator choice is ultimately defined by whether your priority is raw wattage and upfront affordability, or power stability, extended runtime, and silence. It's about matching the quality of the power generated to the quality and sensitivity of the devices you need to run.
That distinction really clarifies things. Knowing that helps you make the right investment. Because investing in a generator, whichever type, really is about buying peace of mind, isn't it?
Yeah.
Protecting yourself against those modern vulnerabilities we talked about.
Absolutely. Avoiding the spoiled food, the work stoppage, the security lapse. It's about maintaining normalcy and safety when the grid fails. It's a smart move in today's world.
So what does this all mean for you, the listener? Hopefully you now have the knowledge to weigh these options clearly, whether your needs point towards the brute strength and value of the traditional workhorse or the quiet, clean efficiency of the modern inverter.
You're making an informed choice to secure your power independence.
Yeah.
Exactly. A smart investment in comfort, safety, and continuity.
And maybe here's a final thought for you to chew on, sort of building on that idea of fuel and runtime. When you're making this choice, think beyond just the generator itself. Consider the whole fuel supply chain in your specific situation.
What do you mean?
Well, the question isn't just about how much power it makes, but also about the fuel it uses and how efficient it is, especially in the context of why and for how long you expect to need it.
Okay.
For example, if you live somewhere prone to, say, hurricanes that cause widespread days-long outages where gas stations might lose power themselves.
Right. Getting gasoline could become difficult.
Exactly. In that scenario, maybe having a generator that runs efficiently on propane, which you can store safely in large tanks for a long time without it degrading like gasoline can, might be the more resilient choice, even if the generator itself was a bit more expensive up front.
Ah, so it's not just wattage. It's aligning the fuel strategy with your likely emergency scenario. Precisely. True power independence means thinking about sustained operation, matching the fuel source and the efficiency to your actual anticipated needs. It adds another layer to the decision.
That's an excellent point. The logistics matter just as much as the technology. Okay, that's it for this deep dive. We really hope this breakdown helps you navigate the world of generators and choose your path to power independence.
Thanks for tuning in.
We'll see you next time.